Why are SUID SGID and sticky bit confusing in Linux? Imagine trying to understand a secret code that changes how your computer handles files and folders. It can be tricky because these special permission bits do things that aren't obvious at first glance. When you look at a Linux system, you see permissions like read, write, and execute. But SUID SGID and the sticky bit add extra layers that can make things confusing. They don't just give or deny access. They change how files run or who can delete what. SUID, or set user id, makes an executable run with the permissions of its owner, not the person who clicked it. That's useful for system tools that need special rights but can be risky if misused. SGID, or set group id, does something similar but for groups. When set on a file, it runs with the group's privileges. When set on a directory, it makes new files inside inherit the directory's group. The sticky bit is mostly used on shared folders like the temporary directory. It stops users from deleting files they don't own, even if they have write permissions on the folder. Now, here's where it gets confusing. SUID and SGID act differently on files versus directories. SUID on a file makes it run with the owner's rights, but on a directory, it doesn't do much. SGID on a file is similar but for groups. On a directory, it makes new files inside belong to the directory's group. The sticky bit only works on directories, and it's all about controlling who can delete files. Plus, these bits show up in permission lists with an S or S. If you see an S, it means the execute permission is also set. If it's a capital S, it means the execute bit isn't set, which can be confusing. Security is another reason these bits can be tricky. SUID and SGID can give users temporary access to perform tasks they normally couldn't. That's why system administrators are careful when setting them. They also don't work well on scripts that start with a shebang line, which adds to the confusion about when they're effective. And because SUID and SGID are similar in name but do different things depending on whether they're on files or directories, it's easy to mix them up. Comparing Linux to other operating systems, Linux offers more control with these special bits. But that control comes with added complexity. You need to understand both basic permissions and how these bits change behavior in different situations. In practice, SUID is often used on system utilities that need extra privileges, like changing passwords. SGID helps manage group workspaces by making sure files belong to the right group. The sticky bit is common in shared folders like TMP to prevent users from deleting each other's files. So, these permission bits are confusing because they change normal rules based on context, affect how programs run, and have security implications. They're part of what makes Linux's permission system powerful but also a little complicated to master.